Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you can find information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help ISU actuary. Here's problem number 2 from the last spring 2019 exam LTAM. In problem number 2 in the written answer section, Gary, who is age 45, has recently suffered a disabling injury on the job. His prognosis is uncertain. His annual salary before the accident was $100,000. Gary receives a structural settlement from MRH Insurance. The settlement is a life annuity starting immediately and payable continuously at the rate of $90,000 per year while Gary is disabled. An additional annuity of $20,000 per year is payable continuously while Gary's prognosis is uncertain for up to 2 years to offset medical expenses. Part A. State 2 reasons why structured settlements often use an annuity format rather than a lump sum. Part B, 1 point. Also Part A was 1 point. State 2 possible reasons why the long-term annuity would replace less than 100% of Gary's pre-injury earnings. MRH uses the following multiple state model. State 0 is being disabled with prognosis uncertain, and from that state you can go to state 1 recovered, or state 2 permanently disabled, or state 3 dead. Of course, state 3 being dead is absorbing. State 1 is recovered, and from that state you can go to state 3 of being dead only. State 2 is permanently disabled, and from that state you can go to state 3 of being dead only and no other state. And then state 3 is being dead, and it's an absorbing state. You were given that MRH holds reserves equal to the expected present value of future benefits. The interest rate is 4%. You have calculated the following table of annuity values and transition probabilities for ages 45 and 47, and you are given continuous annuity starting at age X, starting in state 0 but paid only while in state 0, then starting in state 0 and paid only while in state 1, starting in state 0 and paid only while in state 2, starting in state 1 and paid only while in state 1, starting in state 2 and paid only while in state 2, and the probability of transitioning from state 0 to state 0 over 2 years for age X, the same 2-year transition but from state 0 to state 1 and from state 0 to state 2. Part C. The question is for 3 points as follows. Show that the expected present value of future benefits at t equal to 0, the start date for the annuity payments is $705,700 to the nearest 100. You should calculate the value to the nearest 1. Part D. Show that 2V0, the reserve at time t equal to 2, if Gary is in state 0 at that time, is $689,700 to the nearest 100. You should calculate the reserve to the nearest 1. Part 2. Calculate 2V2, the reserve at time 2, if Gary is in state 2 at that time. 3. Show that the expected present value at t equal to 0 of the reserve at t equal to 2 is 564,000 to the nearest 1,000. You should calculate the value to the nearest 10. Part 4. Calculate the expected present value at time 0 of the payments during the first 2 years. The chief actuary of MRH reviews your assumptions. She asks you to redo your calculations, increasing the force of transition from state 0 to state 1 at age 45 plus t by 0.01 for all t with no other charges. Part E. Part 1. State with reasons whether the value of 2v2 will increase, decrease, or stay the same as a result of this change. Part 2. State with reasons whether the expected present value at age 45 of the reserve MRH will hold at the end of 2 years will increase, decrease, or stay the same as a result of this change. And here's the solution. For Part A, reasons why structured settlements often use an annuity format rather than a lump sum. Well, reason 1, the person who suffered the injury loses income and has unexpected medical expenses. A lump sum payment does not match the structure of payments needed by the injured person, as the person needs income replacement and coverage for repeated medical bills. An annuity provides a better fit for the needs of the injured person. Reason 2, if an equivalent present value is paid in lump sum instead of an annuity, the person injured will have a burden of responsibility of managing his/her investments to produce the income needed. This burden would come at the least opportune time because the person is going to have really other things to worry about. But reason 3, the injured person may lack the expertise and or discipline to properly manage a large sum, lump sum to make it last as long as it is needed in the difficult situation he or she may find himself or herself. Part B. Reasons why the long-term annuity would replace less than 100% of Gary's pre-injury earnings. Notice that it's not the case for the first 2 years. Only after 2 years there is less than 100% replacement. Reason 1, the structured settlement annuity might not be taxed or taxed at a lower rate than salary. Note that injury awards from a court case are generally not taxed as income. Reason 2, paying less than 100% replacement rate provides an incentive for the injured person to return to work. Reason 3, in some situations the injured person may be deemed to be partially at fault for the injury and thus not legally owed a full replacement of income. Part C. The annual benefit paid continuously is $90,000 while in state 0 or in state 2 plus $20,000, but this $20,000 is only paid up to 2 years if in state 0. Thus, the expected present value of future benefits at t equal to 0, the start date for the annuity payments is 90,000 times A bar 4500 plus 90,000 times A bar 4502 plus 20,000 A bar 45 colon angle 2 00. Note that returning to state 0 after leaving it is impossible. You may wonder if there is such a possibility for state 1. That is, can Gary recover and then get injured again and receive benefits again? The answer is no, that would be a different claim. That's why we don't consider it. Therefore, A bar 45 colon angle 200 is A bar 4500 minus the discount factor at 4% over 2 years, so 1.05 to a negative 2, times a probability of survival, probability of transitioning from state 0 to state 0 over 2 periods, so survival in state 0 really, times A bar 4700. So we take out the corresponding annuity after age 47. And all of those annuity factors, annuity values are given in the table, so we just plug them in, and we get approximately 0.5434455. And the expected present value sought equals then 90,000 times A bar 4500 plus 90,000 A bar 4502 plus 20,000 A bar 45 colon angle 200, which we just calculated. We plug them all in, and we calculate approximately 705,668.87, which is 705,700 to the nearest 100. Part D, Part 1. The reserve at time 2, if Gary is in state 0 at that time, 2V0, is 2V0 equal to 90,000 times A bar 4700 plus 90,000 A bar 4702. It's just the present value of future benefits. There's no premium. So we just plug in the values of these annuity factors, annuity values, actual present values, from the table of data given in the problem, not from the standard ultimate life table. We are given the data for this in the wording of the problem. So we just plug those in, and that's 689,670, which is 689,700 to the nearest 100. Part 2. The reserve at time 2, if Gary is in state 2 at that time, 2V2 is 90,000 times A bar 4722, which is 90,000 times 10.623, and that's approximately 956,070. And part 3, the expected present value at time 0 of the reserve at time 2, that is denoted by the expected value at time 0 of 2V, is the discount factor over 2 years, so to bring it back. And then with each of the reserves that are possible, multiplied by the probability of being there, however, of being in the situation of holding that reserve. However, the reserve in state 1 is 0, the reserve in state 3 is 0, so we only have the 2 reserves multiplied by the probabilities of being in those states, state 0 and state 2, and the 2 reserves we calculate. We multiply all of these out, add them up, and we have the answer. The data for this is in the table given in the problem, or we just calculated it. And that's approximately 564,053.82. This is 564,000 to the nearest 1,000. Part 4. The expected present value at time 0 of the payments during the first 2 years is the expected present value of all payments minus the expected value at time 0 of the reserves at time 2, which we just calculated, and that turns out to be 141,615.05. And then the chief actuary reviews your assumptions. She asks you to redo your calculations, increasing the reserve by 0.01 for all t with no other changes. So that's what we will be doing in just a moment. So part E, part 1, we are now assuming that the force of transition from 0 to 1 is increased by 0.01 for all t with no other changes. The reserve at time 2 given state 2, 2V2, is unaffected. This is because the reserve is conditional on being in state 2, and transitions out of state 2 are unaffected by this change of the force of transition from state 0 to state 1. For part 2, we have the probability of transition from state 0 to state 0 in 1 year. That's equal to e to the minus integral from 0 to t of the force of transition from state 0 to state 1, state 0 to state 2, plus state 0 to state 3. Remember, once you don't come back to state 0, so this probability with 0, 0 with a bar above it is the same as what we have here. So it's this method of calculation. 1p4501, the probability of transition to from state 0 to state 1 is the integral from 0 to t SP4500, so you survive in state 0, and then you get whacked by the force of transition to state 1, so mu45 plus S01 ds, and over all possible times from 0 to t, so S can be any time between 0 and t. And then TP45, the same way, it's integral from 0 to t of SP4500, mu45 plus S02 ds. And TP4502, well, that's just regular mortality, but it's the same calculation because there is no return to state 0, so the calculations for states for states 0, 1, for states 1, 2, 3, and 3 are the same. I had a typo here. The 0, 2 was written instead of 0, 3 for state 3. My apologies. Well, once we see this, then we notice where the force of transition from 0 to 1 gets has an effect wherever it shows up. So increasing mu45 plus t 01 by 0.01 will decrease 1p4500 for all t, and hence decrease a bar 4500 and decrease the reserve. Because this is what we see over here. mu01 is right here, and it's with a minus sign, so this quantity, e to the minus that integral, increase the force, decrease the result of this, so that's decrease in the value of the annuity and the reserve. For this quantity here, well, the force is bigger, so you have a bigger chance of being whacked by this decrement of this transition from 0 to 1, and therefore TP4501 will increase for all t. TP4502, it's right here. Well, we just talked about this, that the probability of staying in state 0 is decreased when this force of transition to state 1 is increased. So there will be a decrease in TP4502 for all t, but keep 2v2 as was established in part 1 unchanged, I should have said. Unchanged. Therefore, E02V, the expected present value of the reserve at time 2, will decrease. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.